Hello Year 7, today we're working through the enrichment question of section 4C of the textbook, which is question 14, and it's got a whole bunch of subparts, part A, B, C, D, E, and F. So what I'll do is I'll work through each of these parts one at a time and see how we go. So part A says a 250 milliliter glass of cordial is made by mixing 4 parts water to 1 part cordial. And the two subparts ask, firstly, what fraction of the glass is cordial, and then what amount of cordial is required. So I think the key elements to this question are the fact that we've got 250 milliliters in our glass, and that will be made up of 4 parts water to 1 part cordial. And both the subparts were interested in the cordial, but the first part of the question wants us to know the fraction that is cordial, and then the second part wants us to work out the amount in milliliters. So let's tackle each of those. So for part A, I think what could be helpful to start is if we draw up a diagram representing this glass. So if I just draw 1, 2, 3, 4, 5, let's draw up our glass. And we're told that this total glass will represent 250 milliliters of liquid. And we can break that glass up into parts. There will be 1 part cordial, and then 1, 2, and then 3. So 1, 2, 3, 4 parts water. So in the end, if we've got 1 part plus 4 parts, we end up with 1, 2, 3, 4, 5 parts that we're breaking this glass up into, and one of those will be cordial, and then the remaining 4 will be water. So that's what we're dealing with, and the first subpart of this question, part I, or part 1, asks us to work out the fraction of this glass that is cordial, and hopefully drawing up this diagram makes it clear that out of the 5 parts, 1 of them is cordial. So we could say the fraction of cordial is 1 out of the total 5 parts. And then part 2 wanted us to work out the amount of cordial, and this will be in milliliters because that's the units of the glass. So the amount of cordial would be the total 250 milliliters in the glass multiplied by the fraction 1 on 5. And you could put this in your calculator, or you could do this in your head. 250 times 1 on 5 is the same as 250 divided by 5. And you could use your calculator if you needed to, and hopefully you'd get 50 milliliters as the amount. So that's part A done. Next we'll move on to part B. Let's come back up and read what that says. So for part B, we're told, Feroz drinks 50 milliliters of the glass of cordial and thinks it is too strong. So he fills the glass back up with 50 milliliters of pure water. So basically what's happening is the glass with its combined water and cordial, 50 milliliters of that is being consumed and then replaced with 50 milliliters of pure water. So that will mix up the proportions of cordial to water. And so now, once again, we're concerned with the cordial. And first of all, we're starting with how much in milliliters would be in the glass. And then once we've worked that out, we want to then work out the fraction of the glass that will be cordial. So quite a similar question, just reversing the order. We're now going amount of cordial, then fraction of cordial. So maybe what I'll do is I'll draw up another glass to try and represent what's going on here. 1, 2, 3, 4, 5. So we've got the same 250 milliliter glass of water, or not water, of cordial. But we're told that 50 milliliters has been consumed, so that's now empty. So really, in terms of cordial, the amount remaining is 200 mils would be remaining. And within that 200 mils, we've got the mixture 1 part cordial to 5 parts water. So if I just try and break this remaining 200 mils up into 5 parts, 1, 2, 3, 4. That may not be perfect, but the idea is those are now evenly broken up, so that again we have 1 part cordial, and then we have 4 parts water. 1, 2, 3, 4, and then the first 50 mils is empty. So that is what's happening right now. And then after Firuz decides, well, this is too weak, too strong, he wants to then say, well, let's add 50 more mils of water. So how much cordial would be in this mixture? Well, the way we could do that is we could say the amount of cordial is now equal to, instead of 250, we could take the, before the extra water is added, we could say, well, there was 200 mils, and of that 200 mils, we know that 1/5 of it was cordial, so that would equal, and you could do 200 times 1 on 5 in your calculator, or you could also just say, well, that's going to be 200 divided by 5, which hopefully you would see in your calculator is 40 mils. So that's the amount of cordial. But now, once we add back our water, so that the glass is back now full to 250 mils, the next part of the question was saying, well, what fraction of that total glass now is cordial? And so we could calculate that as the 40 mils divided by the 250 mils of liquid. And if we simplify that into our calculator, I think what we would get is 40 over 250. If we press equals, we're told that that simplifies just to 4 on 25. Panic boom! So that is the fraction of the glass now that is cordial. Okay, so next we're going to move on to part C. So let's come up and read what that's about. So part C says, Firuz drinks 50 milliliters of the glass of cordial, but he still thinks it is too strong. So once again, he fills the glass back up with 50 milliliters of pure water. So the same kind of process. We drink 50 milliliters of the cordial. We then replace that with 50 milliliters of pure water. And we have the same two questions. How much cordial is in the glass now? And what fraction of the glass is cordial? So it's the same process as what we did in part B. Rather than draw up a diagram, I think hopefully you can notice what's going on. So once again, we'd get to 200 mils, but instead of it being 1 part cordial to out of the 5, it's now 4 parts cordial out of 25. So what we can do is say for part 1, the amount of cordial would now be equal to the 200 milliliters that is left after 50 milliliters have been drunk, multiplied by 4 on 25, because that's the fraction that would be cordial. And if we put that into our calculator, we would type 200 times 4 over 25, and we would get 32 mils as the amount of cordial. And then part 2 wants us to convert that to a fraction. So the fraction of cordial. Very similar to what we did in part B. It would be the 32 mils that we've just worked out divided by the 250 mils, since we've added back 50 milliliters of water. And I'll just throw that into the calculator to see if it can simplify. 32 on 250 can simplify to 16 on 125.
Sonic boom!
So that's part C, and hopefully you can see a pattern there. Each time the fraction of cordial is getting smaller and smaller. We began with a fraction of 1 over 5. And to help us compare these fractions, it can be useful to convert them to a decimal. So if I said, well, what is 1 divided by 5 to get it to a decimal? And then we'd see that that is equal to 0.2. And if I multiply by 100, I get that as representing 20%. 20% of the glass is cordial. Then in part B, after we followed this process of drinking and then replacing it with pure water, we got a fraction of 4 over 25, which if I divide 4 divided by 25, I get 0.16, which if I then multiply by 100, that converts to 16%. So smaller. We went from 20% cordial to 16%. And then in part C, the fraction that we ended up with was 16 on 25. And if I do 16 divided by 125, 16 on 125, I get a decimal of 0.128, which if I multiply by 100 to convert to a percent, that's equal to 12.8%. And again, that's smaller than 16. So each time we follow this process, the amount of cordial, the proportion of cordial, or the fraction of cordial, is getting smaller and smaller. So now we'll move on to part D. Oh. So part D. So let's go up and read what that is. Part D says Lynn, so we have a new person now, Lynn, prefers her cordial much stronger compared with Firuz. When she is given a glass of the cordial that is mixed at 4 parts to 1, she drinks 50 milliliters and decides it is too weak. So she fills the glass back up with 50 milliliters of straight cordial. So here we've got drinking the 50 milliliters of the mixture and then replacing that with 50 milliliters of cordial. And then the subparts say how much cordial is in Lynn's glass after doing this once, and what fraction of the glass is cordial. So we're still looking at the amount of cordial, and we start with how much, the amount, and then we ask about the fraction, but the process is slightly different. We're replacing the mixture with straight cordial now. So if we think about what's going on, maybe just for this part D, I'll draw up our glass again, just to remind us with how this is going to look. So 1, 2, 3, 4, 5. Here's our glass. And it was originally broken up into the 5 parts. But one of those parts has been drunk, just like before with Firuz. So we have 200 mils remaining. Of those 200 mils, that then remained into its 5 parts. So if we break that up into 1, 2, 3, 4 and 5 equal parts. So it started off with just the 1 part of cordial to the 4 parts of water. That's what would have been left after Lynn drank 50 mils. But instead of then replacing that part that was drunk with water, we're replacing it with cordial to make it stronger. So part 1 of part D wanted us to work out, let me just double check, I think it was the amount, part D, yes, how much cordial is in Lynn's glass after doing this once. Well, the amount of cordial in the glass to start with was 50 mils, but then it got drunk, and then the fraction that would have been left, we worked out in part B, once you drink 50 mils of the original mixture, there's 40 mils of cordial left, but then we're adding to that another 50 mils. So I think the amount of cordial would be equal simply to the 40 mils that we would work out by getting the various proportions, but of the 200 mil, we already worked that out when we were doing the calculations for Feroz, but then we're adding to that the 50 mils of cordial when we're topping it back up, so that would give us 90 mils of cordial.
Sonic boom!
So there we could do that calculation a little bit more quickly, relying on the calculation that we had already performed earlier. And then part 2 wants us to work out the fraction of cordial. And here we can take the 90 mils that we've just calculated and put that over the 250 mils of liquid that there now is. And I'll just put that in the calculator to see if that fraction simplifies. 90 over 250. And that will simplify to 9 over 25.
Sonic boom!
So that's the fraction. Now we'll move on to part E. So let's go and read what part E says. Part E says, like Feroz, Lynn needs to repeat the process to make her cordial even stronger. So once again, she drinks 50 milliliters and then tops the glass back up with 50 milliliters of straight cordial. And the same two subparts. How much cordial is in Lynn's glass now? What is the fraction of the glass, or what fraction of the glass is cordial? So let's come down and think about this process. So, in terms of part 1, I don't think we need to draw a diagram again. Hopefully it's quite clear what's going on. The amount of cordial that would be in the glass after the 50 milliliters is drunk would be the fraction we just worked out, 9 over 25, multiplied by the 200 mils that is left. And if we put that in our calculator, 9 over 25 multiplied by 200, we get 72 mils is how much is in the glass. But what's happening in this process is, of that 72 mils, we then add the 50 mils that we top up when Lynn realizes it's not strong enough. So we end up with 72 plus the 50, and if we put that into our calculator, so 72 plus 50, we get 122 is the total amount of cordial that remains once that whole process is carried out.
Sonic boom!
And then for part 2, we want to calculate the fraction of cordial that remains after that process. And just like we have with the other sections, that would be the amount of cordial, 122 mils, divided by the 250. And if I put that into the calculator, 122 over 250 can simplify to 61 over 125.
Sonic boom!
Now, it can be interesting to see what's going on with Lynn. So Lynn started in the same way as Feroz. The amount of cordial was 20%. That's where this whole thing began. And then after the first iteration of the process for Lynn, she ended up with a fraction of cordial of 9 over 25. And if we convert that to a percentage, we do 9 divided by 25, and that's equal to 0.36. And if I multiply that by 100, we see that that's 36%, which is bigger than 20%. So hopefully it's no surprise, the percentage of cordial is getting higher. And then after the next iteration, again, the fraction of cordial was 61 over 125. And if I put that into the calculator, 61 divided by 125, that converts to 0.488. And if I times that by 100, we see that that is 48.8%. And again, it's getting higher once again. And that leads us to the final part of this question, which is part F. And it says, if Feroz continues diluting his cordial concentration in this manner, and Lynn continues strengthening her cordial concentration in this manner, will either of them ever reach pure water or pure cordial? And the idea is to discuss this. And I think, as I've highlighted, for Feroz, the percentage of cordial keeps going down. He went from 20% of cordial to 16% of cordial, and then to 12.8% of cordial. So it might be tempting to think, well, if we keep repeating this process, Feroz will end up with 0% of cordial, and so there'd be pure water because there's no cordial. And conversely for Lynn, she starts at 20% cordial, then moves up to 36%, and then up again to 48.8%. So it might be tempting to think, well, for Lynn, she will end up with pure cordial instead of pure water, because her percentage of cordial might end up being 100% and 0% water. Now, rather than repeat these calculations manually over and over again to test that, I think what would be helpful is to put this into a spreadsheet and let those calculations get repeated in a more smooth way. So what I've done is I've created this spreadsheet, and I'll explain what's going on. So I've got one worksheet for Feroz and one for Lynn. So over for Feroz, we have our starting situation where the total drink is 250 mils. The fraction of cordial, we're told, is 20%, or we work that out as 1 part of cordial out of the 5. The amount of that is the percentage, 20% times 250, which is 50 mils. And then what's left, the 200 left, is water. Now, after Feroz drinks 50 mils, there's only 200 left in the glass, but the cordial fraction is still 20. That leaves the cordial amount of 40, with remaining water 160. So this is what we were working at manually. We then repeated the process and we got 32 mils of cordial, which translates to 16%. And what I've done with the spreadsheet is I've repeated these processes. So each time we drink 50 mils and then replace it with water, and the percentages automatically now calculate. And if we scroll down, we see the percentage is getting smaller and smaller and smaller. So we started with 20, got to 16, and then 12.8, which is consistent with the calculations we were doing manually. Then the percentage gets to 10.2, 8.2, 5.2, and so on. And we see that if we keep doing this enough times, we do eventually get to approximately 0% of cordial, which would mean pure water. Now, there's a lot of rounding going on here, so it's not perfect yet. But if I'm going to 1 decimal place of precision, then effectively, on the percentage, then we are effectively at 0%. That happens after 27 iterations of this process. But if we wanted to get there with more precision, we could just keep going. But the main point is, eventually, after some number of repeats of this process, we will eventually, approximately anyway, get to pure water. Now, in a similar fashion for Lynn, same setup, start with the 250, 20% of its cordial, and so on. This time the percentages get bigger because we're replacing the mixture with pure cordial. So the cordial fraction goes up to 36, then 48.8. That's what we calculated manually. And then it keeps going up, 59, 67.2, and so on. And if we scroll down, we see that eventually we get, again, to 1 decimal place of precision, 100% cordial, so pure cordial. And this time that happened after 34 repeats of the process. And again, it's not perfect. There's a bit of rounding going on here, but the idea is there. If you kept doing this forever, you would eventually get to pure cordial.
Sonic boom!
So that's it for that question. Hopefully that's all made sense and you've been able to follow along, and that's kind of unpacked what's going on here with the fractions and the repetition of this process, and how the different concentrations of the cordial change when we replace a mixture with either pure water or pure cordial. So hopefully that's all made perfect sense to you, and tick boom.